So today's question is top of page 43, it's figure 3.15. So where we have a hemisphere, which is our green, and we have our sphere, which is our yellow. So the both of these are in contact. So the elevation of a hemisphere, A, which is the green one, sphere B is the yellow one, is resting on the horizontal plane, which is shown in our figure 3.15. The solids are in contact. Draw the plan and elevation of the solids and show the point of contact in both views. All right, so this is our information, this is our elevation. All right, so let's draw what we have. We can get everything here. We're able to get in our hemisphere to tell us exactly where our center point for B is as well, how much it's in from the edge of the hemisphere. So let's get that in and we'll worry about the rest in a second. All right, just make sure you know your steps before you just drive on watching the solution. If you don't know your steps, you're going to get lost if you don't know why you're doing them. So that is my X, Y line. Our hemisphere A has radius of 50. Okay. Do it nice and light first, because there is a piece that's chopped there from B. There is A popped in. Now it tells us B, our sphere, is 18 millimeters in from the edge. So the center point of it is 18 in from the edge. So we can do a light line up. And it tells us the radius is 24. And the sphere rests on the horizontal plane, which is the XY line. So we just step up 24 millimeters from the ground. That is our center point. Compass, so put it on our center point, stretch it down to the baseline. And you can put that one in nice and heavy. Now what we'll do then is we'll go straight back to our hemisphere. And we'll heavy that in. Put in our dotted lines using our compass as well. All right, now that's it in elevation. Now what we'll do is we'll pop it into plan here now. So we'll bring the center point of our hemisphere down. We'll bring one of the either side, doesn't matter, one of the outsides down as well, so it gives us our radius. Down, I'm just giving a little bit of distance so they're not sandwiched up. I normally step down our 10 mil and I step down the radius again then, which is 50. What I'm going to do, instead of measuring back up to the dot, I'm just going to go to the outer point here. I drop down. Do it in nice and light, because again there's a portion of it gets cut off. Now not a big portion, but something gets cut off. Alright. Now we can bring down our center point for our sphere B. Only problem is we don't actually know along here where it is. All right, so this is where it just changes a little bit. And what we need to do is we need to look at it at an edge. So we need to rotate this whole object. The hemisphere and the sphere need to turn, so we can look in this way basically, and we need to see where they're making a contact, where they're making a point of contact. Easiest way of doing this is rotating or moving this, rolling along the ground, this sphere, rolling it along the ground till it gets out here and it just hits the edge of this circle or this hemisphere here. All right, so it's the easiest way, handiest way. What we do is we take our center point here and we're going to just bring it across nice and, so we've this brought horizontally across. Now we need to locate the center point. We know it has to be 24 away from this here. So what you're going to do, excuse me, we want it to be 24 away from the edge of the hemisphere. So you can't just get your ruler and measure out, all right, because it could be in any location. And what you could is you could be out by half a mil or a mil. All right, what you're going to do is you're going to add, so back to junior cert, you're going to add the radiuses together. All right, so we're going to add our radius together, which is 50 for the hemisphere, 24 for our sphere, and add them together, so you get 74. Right, we're going to set the compass now to 74. Set your compass to 24, and you're going to swing it from a constant, which is the center point of the hemisphere. You're going to swing it out there. Where the crossover, that is the center point for sphere that got, or sphere B that got rolled over. All right, pop that in so. Now we'll do that one light, okay, because we only need to locate the center point. You probably wouldn't have to put it in, but we'll put it in just to show you what we're doing. So we've basically rolled our sphere over to this location so we can find where they hit one another. To get the point of contact between two circles, you join their center points. Center point to center point. Where they cross over here is our POC, a point of contact. Again, this is all junior cert stuff here. All right. Now, we need to bring, we can't just bring this down yet, we don't exactly know where it is. We need to bring our center point here down. Now we need to know where it stops first. So because we've moved the ball, we're looking directly in at our two solids in contact. That means we're after rotating their point of contact to a flat edge here. So like its extremities. So it's extreme generator, somewhere around here. So we put in our horizontal line through the center point. We'll drop our center point of the sphere B in its location, its new location, which is here. There it is there. Now you don't need to redraw the circle. All right. All we're going to do now is we know that's where we moved it to. So we've brought it down in this direction here. All right. We already have the center point, and we know it's somewhere along here. We have its location somewhere along here. We just need to find exactly where. So what we're going to do is we're going to rotate this around. So here's our center point of our hemisphere, which is going to be our arc for the whole thing. There it is there. Stretch it out. Rotate it around. All right, rotate it around where the crossover. So I'll just stick a little arrow on this as well for you. Let's rotate it around where the crossover here. That is the center point for sphere B in plan. So go back up to elevation to get the size of it. Pop it in there. You can pop it in nice and heavy now as well, because that one is sitting over the edge here. While we're there, we'll jump back to the hemisphere in elevation, or in plan I should say, and we're going to heavy that one in. Remember, heavy in your main object, leave the rest in construction line, let them fade into the background. All right, we'll pop in our dotted lines using our compass as well. And we have our dotted lines. And last but not least, we will drop down our point of contact. So you're going to drop your point of contact onto this horizontal line. So drop that POC down to there. All right, so that's where it was. You're going to rotate it. You're going to put steel on the center point, stretch it out to where that point of contact is, and you're going to spin it around to here. Don't know where it stops yet, but the exact same as we've done up here. Join center points. To find a point of contact, you join center point to center point of a circle. And that should give you the point of contact. So as this rotates around, that there will be your point of contact, your POC. So I'm just going to go back over this rotated line in pink, my pen, so you can see it. I'll go back over this one as well, just to show you. That's where the crossover, that is our POC, point of contact. All right, so that is the question, top of page 43. Okay.